For many years, a lot of the focus of digital transformation has been on business to consumer type of industries. And then we saw a lot of industrial clients starting to really use this technology to benefit their business. And we heard a lot, or I heard a lot from my clients that, somehow in the industrial world, digital transformation is different. So we decided to sort of explore the topic a little bit more deeply. And in that context, I'm really, really happy to have Mike Ambrose on campus at IMD today. Mike has got a ton of experience, which he'll share with you in the industrial world. And we're going to kind of explore what's the difference and what does it really mean to do digital transformation in a big industrial, traditional organization like aerospace for us. Mike, over to you.
Well, thank you so much, Didier, for having me here. My very first time to Switzerland, so thank you for the invitation. So just a little bit about myself in my career is that I just completed an almost 40-year career at Sikorsky Aircraft, which is now part of Lockheed Martin. And the interesting perspective on that is that I was at the beginning, the genesis of digital transformation. And so in my career, which started as a design engineer, manufacturing engineer, as ultimately I became a system engineer, I then became an executive in the factory. I ran the largest factory at Sikorsky Aircraft, which means Sikorsky Aircraft is helicopters, some of the best, most sophisticated helicopters in the world. And after I had built a lot of the transmissions and the rotor components that go into helicopter, I went into program management, spent a lot of time overseas and some of our overseas customers, went back to engineering, led engineering, was the chief engineer, vice president of engineering at Sikorsky for a number of years. And since I've retired after 40 years, I'm doing consulting, and it's been fascinating because not only do I continue on the digital transformation journey as I get to work with startups, I get to work with suppliers, it's given me a whole different perspective on the challenges and opportunities of digital transformation.
Great. So look, in the last and I want you to either confirm or say no, but we have seen a very big acceleration in our industrial clients in, I would say, 5-6 years, the last 5-6 years. There seems to be a lot of interest in how do we actually use these technologies to really improve the business, improve the customer experience, and so on. Is there a reason behind that, or?
Yes, well, there's actually two perspectives on that. One is, like I said, I was at the genesis of digital transformation. So with complex industrial products, this journey actually started in the early 1980s with CAD/CAM, computer-aided design, computer-aided manufacturing. That was a foundation. It is true that we've seen an acceleration over the last 5 to 10 years, and that's really related to the computing power and the ability to now go beyond that classic computer-aided design, computer-aided manufacturing interface, which has been so beneficial in so many regards, is that now you can extend that to other parts of the product value stream. And so that's the acceleration that everyone's seeing, is the ability now to have the computing power to be able to connect more parts of the digital thread.
Right. So computing power, data, I'm assuming, is all the availability and the convergence of these technologies has really helped to start rethinking the industrial value chain, if you say.
Yes, and it's probably just because the value chain has always been there. It's been very serial for forever, and that's one of the opportunities and challenges that we even have today is that how do you break through those silos now that you have the ability to connect the data throughout the entire value stream so that you can do things simultaneously instead of doing them serially.
And silos, you mean R&D, over to manufacturing, over to testing, over to...
Yeah, I mean, starting with a customer need, with requirements, and when you're talking about things like engines, helicopters, fighters, is that there's literally could be thousands of requirements. And so that's been one of the classic challenges is how do you take those thousands of requirements and then convert that into a concept, then to a design, then to something that you build, that you have to assemble, that you have to validate and verify, and then eventually it's going to be out in the field, and that could, it could take 10, 15 years to go and do all that. But then when the product is done, it's got a life cycle of decades.
Right.
If you do it right.
So it's a pain up front and then...
yeah. And if you make a mistake up front, it's just...
You pay for it for a long time.
Yeah.
Yes. And so most organizations are complaining to us as educators, as we have silos, we find it really hard to break silos. How do you do that?
Yes, well, as I said, is that I think one of the blessings of my unique career is that I had so many different positions throughout that product value stream. And so what I realized early in my career is that, digital transformation really had its genesis in that computer-aided design, computer-aided manufacturing. I lived it. I was actually one of those computer jockeys that the reason I went into engineering was before there were computers, and I was a really good artist who was good at math. That makes no sense today. But what it allowed me to do was to see the benefits is that as you were able to connect the data, that you can now go and do something with it. So the foundation for how you break through the silos is really manufacturing, is we have to build something. And so when I became the chief engineer, is that I realized is that if we're gonna go and accelerate transformation, is that it needs to start with where we're actually building the product. And so in assembling the product, because those are the skills that have the best understanding of how that data can correlate into better quality, faster schedule, better capabilities. And so I had a mantra, is that historically manufacturing engineers, and I can say this because I was one at one point in my career, they're kind of like at the bottom of the totem pole when it comes to technical skills. In the helicopter aerospace, you've got your aerodynamicist, you've got your dynamicist, the ones what I used to call the 100-pound brains. And then manufacturing engineers often didn't even have a 4-year degree, but they know how things got built. And so what we did is we're going to turn our manufacturing engineers into system engineers. And they're the ones who have the best understanding of how all this data throughout the digital thread ultimately finds its way into building and assembling a product that then goes into the field. And that was the thing that allowed us to accelerate much, much faster. By having manufacturing engineers now be able to break through those silos of design requirements, logistics, even to the point of interfacing with outside of engineering and outside of manufacturing to finance and to other parts of the organization. Being able to go and speak that language, teaching them to speak the language of system engineering, and ultimately the term used today is model-based system engineering. That's the aspiration, is that the more connected the digital thread is through models, the better you're going to be able to get benefits. But the key to breaking through the silos was to really turn manufacturing engineers into system engineers.
And this is something that you train these people, or you just hire different people?
Well, we started with hiring different people for the most part. I mean, certainly we had very talented manufacturing engineers who ultimately knew how to build the product, who had the capability to go and learn new skills. So in the end, it was a combination. It was this dual strategy of take really bright people who had practical knowledge and then give them the ability to think differently. And for many, they readily embraced it because it was part of what they naturally did. And you supplement that with people who had the 100-pound brains, but said, look, a career in manufacturing engineering is a very exciting career with ultimately opportunities to become executives and to get other positions that in previous generations probably wouldn't have been there. Okay. And so it was a combination of both.
And it feels like what you've done is, because we've been talking a lot about system engineering over the years, is that you've opened the minds of your manufacturing engineer like 360 degrees.
Yes.
To see the end-to-end from design to spec to delivery of the product. But still, at the end of the day, did you not face the old organizational issues that, regardless of how a person sees a product, you still have silos, right?
Always, always, always. And that's where leadership matters, is that, just from perspective is that my master's degree is from MIT. It's engineering management / system engineering. And so and it was a wonderful, wonderful, the whole curriculum was geared towards thinking in systems. And so what I realize is that you do have to marry the organization with the processes, is that it's not enough just to have the processes, that it does take organization and it does take top-down leadership. And ultimately, it's that top-down commitment to be able to go and say, no, we are going to think differently, we are going to do things differently, that ultimately allows you to make progress. There's always going to be resistance. We're human.
Yeah.
And so people will be people because they feel threatened or they don't understand. And so the leadership matters when you're trying to do this type of transformation.
And presumably, Mike, you face the same thing that we face always in digital transformation or any transformation, is that you have to have aligned, leadership matters when it's aligned also. You need to increase collaboration and working across these famous silos through, I don't know, governance or something like that. Did you have to face all this? Or?
Of course, and what's interesting is we talk about, well, what's one of the main differences between what I've spent my career doing and what I've learned since I've left, helicopter business, is that it is a long cycle. And so the continuity of the vision, the strategy, the culture, it matters, because ultimately whatever you do from a transformation standpoint is going to have to go across many chief financial officers, it's going to have to go across many CEOs, many CIOs. And so there needs to be a foundation that is able to go and continue after organizations change, after customers change, after customer needs change. And so the way I looked at it is that I even stopped using the word digital transformation. And I use the word digital integration, because it is about the thread. And I do think that that's something that is transferable regardless of the product, whether it's a shorter cycle, longer cycle, is that the more you can think in terms of the thread, and those threads are interfaces, those are stakeholders that all have to be considered as you go through your transformation journey. And if you start to think about it in terms of an integration, you're able to understand is that there are certain value propositions that matter to each one of those stakeholders. At the end of the day, there's a customer and there's a business. The business has to make money, it has to serve a need, there has to be a customer that's happy and believes that they're getting value for what they're paying for. And so the thing that really, really makes a difference and was able to go and help us make sustainable changes in the business was how we measured it. And so measuring for us is that we have public companies have quarterly reporting statements. You have to show every quarter that you're making sense and that your investments make sense. So you have to have a combination of near-term metrics that show that we're making intermediate progress and hitting milestones on our journey, but then always keep track of what the longer term is. And this goes back to something is that because if you look at it from an integration standpoint, as you look at it as a thread that goes from design to build to assembly to a customer, is that as you look at each of those, there are value propositions along the way. And the more that you connect the thread, and this is where the fact that there's more computing power, there's more data, allows you to both plan and measure easier than you did 10, 15 years ago. It creates the value proposition that allows for that sustainability, that allows for organizations, that allows for leaders to maintain that commitment to a transformation journey.
Right. And then when you mentioned, so we've talked a little bit about the organizational part and the people part, that's very important. But you keep referring to the digital thread, and is that also an integration, as you call it, of data, computing power, analytics, all these things? Because a lot of our clients today are still struggling with integrating any data before they can be analyzed. But in the products that your products are so complex that data is at the heart of it. And I'm trying to understand what this digital thread is really about from a data and computing power perspective.
Yeah, and I'll always use the term, so at the end, there's that digital thread would feed something that we call a digital twin.
Okay.
And digital twins to me are aspirational. I don't think it's something you ever achieve. It's kind of like the holy grail.
Right.
Is that, however, the more you connect the data, I think it's good because it's an analogy that a lot of people a lot of companies can understand, is that digital transformation has shown its first benefits, and in many cases its biggest benefits when you talk about complex products with manufacturing, is that over time we looked at it as that if you connect the design to the manufacturing to the build, I expect to see at least 70% improvement in quality. I expect to see at least 15% reduction in cost and at least 50% reduction in schedule, and also cost reductions because of the schedule reductions. That has been demonstrated, not just by myself, but many companies. That's about what you should target, is that's because the data between the design and the manufacturer has several decades of legacy, and you can connect the design to the tooling, to the build, relatively, I'll call simple, because we've been at it for so long and it's known. Now as you take that to more complex parts of the digital thread, as you start to extend that to, in my case, to the design, the actual design, where you go through, literally could go through hundreds of different iterations on how you would design like a rotor blade. Very complicated in the world of helicopters. There's so many, there's thousands and tens of thousands, maybe millions of different variables that go into that. So how do you go iterate that? Well, the computing power allows you to go do that, and at the same time, simultaneously, you're figuring out how to build it. We developed a term called X before you X. And so as you start to look at the digital thread and you start to connect more parts of it, this concept of X before you X, design before you design, so little d before you big D, design, build before you build, fly before you fly. Because ultimately, by the time you're flying something, you really have better gotten it right. But if you can actually fly it while you're designing it, while you're conceiving how to build it, you can go through literally, and this is where things like artificial intelligence come in, is that you can go through hundreds and thousands of different simulations to optimize it, where, you know, I said when I first started, is that you pretty much had to get it right on your first or second try. And so otherwise there would be huge cost implications, and that's part of why it takes 15, 20 years. And now today you can go through those iterations and vet that out. So there is an aspiration that you should be able to reduce that cycle. So whereas today it's 10 to 15 years to connect that digital thread and go from I want something, I need something, to something gets delivered, theoretically you should be able to reduce it.
Right.
And so that's why as you connect the digital thread, you start to leverage not only the automation of being able to use that data to go and do things quicker and be able to use the same data, but also to use simulation. And the simulation is the X before you X.
Okay. Which is where the digital twin concept is very useful.
Yes.
Yes. So so I mean, the data you mentioned was amazing, right? I mean, we're not talking about incremental improvement in production design and all this kind of, you're talking about big numbers. Presumably that's what spoke to your CFO and allowed him or her to actually give you the investment that you required.
Yes, and of course it's show me the money, so show me the benefits. And this is where, you know, I do look at the digital transformation journey, I look at it as both evolutionary and revolutionary. Is that the evolutionary part is that you do have to show me. You know, CFOs, I mean, they've got their customers and they have to show that there is a value proposition. So even though it starts with, I can hold a physical thing, I can hold a gear, or I can hold, a rotor, you can't really hold a rotor head, but you can see it. And you can see the direct benefits of that automation of going from design to build, and that I can say, oh, wow, the quality is better, I did it faster, with more capability. Right. What becomes harder is when you start to look at things that you can't readily touch. And so, a CFO will say, well, that's a lot of investment to go buy that supercomputer. Is there another way you can do it, because I don't have the $5 million this quarter to go invest in that. And so it is about building upon foundations to show them that there is a value proposition. And I've told many investors, many people, is that if you give me $1, I will save you $5. And this is how I'm going to do it, and you can measure me to it. So that's where the measurement is so critical. Yeah. Is that you need to understand what is that value proposition, how are you going to be measured, because ultimately that allows you to have the consistency, the commitment to the vision.
But it's interesting to just reflecting a little bit, because so many of our clients are struggling with the data side. Mm-hmm. And integration, how to use it and all this. You seem to have not treated the data integration as an IT problem, but you built it, the necessity around the end-to-end product design, right?
Yes, very, very good insight. Yeah. It's interesting because I do believe in wonderful partners in IT. In fact, I think this is where you have to look at it as this system engineering, this thread, is that the more you can break through the silos and be able to have people share that common vision, the faster you can go. and that even though there does need to be an IT department, there needs to be an engineering department, but being able to have those collaborations where you think of it as the thread. And I've seen, I think Tesla, I think Musk actually, on purpose or not, has done a very good job of being able to break through those silos and allow as a thread. I mean, I don't know if he calls it that or not, but that was really my education, going back to really what I learned at MIT, is that you have to look at it as interfaces. And if you consider the interfaces and the stakeholders that tie into that interface, you look at problems completely differently. You really do.
Now let me ask a question, because this notion of interface is really interesting. I can see why using virtually a different mindset from saying it's a problem, we need to integrate, blah, blah, blah. No, let's think about what we're building as a product and build this thread, as you call it, across it. But then there's another part of the integration that you probably have hundreds of suppliers. How do you connect your threads to them?
Yeah, now this has been some of my education since I've left, the aerospace industry, is that I've been consulting with many of those suppliers. And, and I'll start with is that they're not buying, a lot of them aren't buying into, not all of them, but a lot of them aren't buying into transformation. I mean, they've been in business and been successful for decades. Don't understand, can't make the investments. OEMs, and in the case of many of our products, you have large governments that are requiring data to be in certain formats, requiring compliance to how they want to see the data. And supplier says, well, one, I can't afford that. Two is, why would I give away my IP? And so this is where the interfaces come into play, is that ultimately, my education was and I know that this has been some of the challenges we have, because typically large complex products, it's over 70% of the parts come from somewhere else. Is that if you look at it differently, if you look at it interfaces, so not only internally, but externally to your supply base and also to your customers, who in the case of complex products, they would like that data too. In fact, they often require that data. If you look at it from an interface standpoint, it does allow you to look at the situation differently, because those interfaces are really attributable data. And don't have the answer to it yet, so I think this is another aspirational goal, that ultimately the more you can connect that, if you look at that interface in terms of what do I need to know about that actuator, what do I need to know about that circuit, you really need to know that output that you can then go and treat it as an input to your digital thread. And so if you're looking at it from a complex product, an actuator, you need to know pressures, you need to know cycle rates and things like that, is that if you're able to break that into data that now you can attribute, that is able to feed this digital model. Right. And so that way you can go to the requirements, you can go and feed the design, ultimately you can get quality data, because that's the information that in the past has been very manual. Now you can go and automate it. And that is information that theoretically shouldn't impact like the IP. Right. Now, that's a very naive, simple way of looking at it, so to speak, but I think it starts there, is that looking at that interface from a supplier customer standpoint allows you to manage something, because I don't need to know everything about that supplier part. In some cases, I might not really need to know anything other than it just needs to thread into a whole. And so that's where the intelligence, that's also where like artificial intelligence comes in, because things like AI can tell me, well, what is important about that interface? Where again, quality data, I've seen examples of where you get engineers together and they could literally come up with hundreds of things that matter, when maybe it isn't, maybe it's much less. Yeah.
So that's interesting, because so if I understood right, you're seeing potentially, and again, it's not there today, but potentially a really connected platform between what you've built with your thread internally, what your key suppliers are feeding you with, and what they need also to build the right parts, I guess, but only on the limited set that maybe AI can help to narrow down. But you also mentioned connecting to your customers, right? Because they may need some information. So we're virtually talking about a platform that would be open to your ecosystem, being customers, suppliers, and others, where people will find and pretty much deposit the kind of data that's required to make this process as good as possible. Now, you and I grew up in a world where this was not natural, right? It's my data, it's not your data. Why would I pass on my data to you? And do you think this is going to get better with the next generation?
Well, obviously, it all starts with the customer. In the case of complex manufactured parts, the customer pays for a lot of this, and so obviously their vote matters. And those customers saying, "I want the data. I'm paying for the data. I want the data," and so that will drive a lot of it. I also believe that if you look at it from a commercial perspective, so commercial engines, commercial planes, for example, there's a lot of value in ultimately this digital twin, which is the holy grail of what you're trying to achieve, is that being able to connect these thousands of requirements into a model that you're now able to trace. So if you think of like the triad of why digital transformation really makes a difference, or how you make a difference, it's the automation, that's where it started. It's the simulation, the X before the X. The third is traceability. And so for these complex products is that, as requirements evolve, as requirements become more complex, and in my career is, it's orders of magnitude, in terms of what a helicopter does today versus, it still might look the same, on the outside, completely orders of magnitude in terms of sophistication. And that's the requirements. There's a need to do that. And so this idea of having what starts as a model-based system engineering, being able to trace it through the design, being able to trace it through the build, manufacturer, the verification, validation, then in the field, by tail number, by specific aircraft, because every aircraft, even though you standardize it and you automate it and you do all this to make it the same, it's going to live its life differently. Every person is different. Identical twins are going to live different lives. And so having that type of pedigree and that footprint of an individual aircraft or individual engine traced back to its whole entire history has value to customers. And so that's ultimately what's going to drive it. Now, there's not enough, you think about where we're going to store all this data, and there's a concept called single source of the truth that sounds simple, but at the end of the day is that's huge data, potentially data warehouses of information. Again, I think this is where AI and this is where, just the way you approach it and manage at the interfaces allows it to be manageable.
Right.
Yeah.
Right.
Yeah.
So you're saying two things. So if I go back, one of the internal integration, as you call it, was really this notion of systemizing the mindset, from beginning to end, and aligning everyone in the organization, which is already not very easy in most of organizations. And then you're saying the pressure point for moving from that to really a data platform that can be connected to the entire ecosystem, the pressure point really comes from the customers. Yeah. Yes. Interesting.
And the customers evolve, and and requirements evolve, and so, which is why when we started out is that at the end of the day, there's always a customer, there's always a need that you're trying to fulfill, and in the case of complex products is that those needs could evolve over decades.
Right.
And so that's also where like the digital thread comes in, is invaluable, because it allows you to go in, if you have modular designs and if you have ways to go in and do like plug and play for your avionics and the type of things that a digital thread should enable, it allows that product to be more viable to requirements that you can't even imagine today.
Right.
And so that's actually a big objective for these long cycle type products.
Right. Let me ask you a couple of questions so we can conclude on that, because this has been fascinating. If I look and open the box on one of these big industrial companies like Sikorsky Aircraft or others, full of engineers, people who understand data, smart people on a number of materials, on a number of... this is not your traditional population for a B2C company. So when it comes to digital transformation, do you think that you have an advantage, or is it just as difficult as in any other industries?
I think it's more difficult.
Yeah.
Yes, yes, because well, part of it is because of the silos. Is that all very skilled, but when you look at the products, complex manufactured products that are highly engineered, highly technical. You said hundreds of requirements, probably millions of interfaces. The orders of complexity is, and this has been some of my education, since I've left the aerospace business, is that the complexity is significantly beyond anything that you would see like in a typical business to customer directly.
Right. So complexity, yeah.
Complexity is a big thing, and also complexity in every dimension, complexity of organization, complexity of the customers, complexity of the products. And so all that plays into, while you focus on the thread, and that helps keep you grounded.
Right. So if you have the last question, so if you had to give, 2 or 3 of your best piece of advice for industrial clients that are either in the middle of their transformation and struggling, or starting a new digital transformation, what would those 2 or 3 sort of nuggets will be?
Yeah, in my experience, it starts with the leadership, and it really is that commitment to and I'll use the term digital integration. I do believe that for long cycle businesses, the commitment to digital integration is an evolution beyond digital transformation, because it's going to have to outlast different CFOs, different CEOs, different customers, different requirements. And so the concept of a digital integration, of a digital thread, is paramount to being successful. The second would be is that think of it in terms of evolutionary and revolutionary. Is that the evolutionary is that the more you can connect and show value as you connect the digital thread, you're justifying the investments, you're building knowledge, you're building capabilities. The revolutionary is technologies emerge. I mean, we weren't thinking about artificial intelligence even 5 years ago. But that's opened up a whole paradigm of the whole X before UX, the simulations that didn't exist. And a lot of that is driven by the computing power. And I think the third is that you have to understand the stakeholders, and this is why managing the interface is so important. We talked about the supply base. You can make a lot of benefits. You can get a lot of benefits by focusing internally, but you're going to really get the benefits as you start to consider all of the interfaces. And so those would be the 3 major things I'd offer.
Thank you very much. I'm sure they will really appreciate. Mike, it's been great to have you at IMD. Thank you so much for your insights. And as I said, I think the world of industrial companies is really moving very fast, and we're delighted to have you here.
Well, thank you. It's been wonderful.